All right, guys, so our next unit is going to be talking about Newton's laws, right? And that starts chapter 4, right? And so I'm just going to kind of go through and talk about a little bit of history on Newton's laws, and then we'll kind of continue. Okay, so, right, so kind of the history of motion starts with Aristotle, right, and his concept of motion. Okay, so basically he said that a object's normal state is when it's at rest, right? And basically a force is needed to keep something moving, right? So that without that, it's not going to happen. Okay, natural motion is up or down. Okay, and so this caused by the elements sorting themselves out. Okay, and this is what kind of early philosophers thought. Okay, but natural motion for heavenly bodies is circular because it does not end. Okay, and then he talked about his violent motions. Right, so basically, due to imposed forces such as wind pushing a ship or something pulling a cart. Okay, and so, right, so what was Aristotle's basic error, right? And it was kind of this, right? He didn't understand friction was a force. Okay, he just kind of he did not ever take that into account. Okay, and then Galileo comes along with his concepts of motion. So he was around from about 1564 to about 1642, right? A force is a push or pull, and that concept is still used today, right? And so friction is just a force that occurs when an object moves past each other. And you've probably noticed that any time that, right, if you went and you rubbed your hands together, it would start to create heat. Okay, so basically friction is really due to some tiny irregularities in the surface. Okay, and so the more irregular that surface is, the greater the friction. Okay, so only when friction is present is a force required to keep something moving. Okay, and so, but basically, and so he says, right, unlike Aristotle, right? So basically, Aristotle said that, right, it would just keep moving, right? And so it was a force that had to keep it moving. And so Galileo comes along and says, no, 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 right? So basically, friction is what's slowing things down. Okay, so Galileo used a couple experiments, right? So basically, he rolled a ball down a ramp, and he saw that it came up to the same height. Okay, and so right when the ball rolls uphill, it was slowing down. Okay, what happens to the ball on a level surface, right? So Galileo concluded that it would roll forever, right, as long as there was no friction. Okay, and so then steps in this idea of inertia, right? Inertia, you can think of it as a resistance to change, right? And so Galileo concluded that all objects have some degree of inertia. Okay, and so he contradicted Aristotle's theory of motion, right? In that the natural state of an object was to keep on doing what it's already doing, to resist a change in motion, right? And so we see that, right? And so anytime you think of a large object, it takes a fair amount of force to get that object started moving, okay, because of its inertia. Okay, and so no force is required to keep the Earth in motion around the sun because there's no friction. Okay, it's never going to slow down. Okay, and then in steps Sir Isaac Newton, right? He was born in 1665. Okay, and so he kind of built on Galileo's idea. Actually, he was only 23 at the time that he came up with our three laws that we still use today, all the way from the 1600s. Okay, and so, right, so Aristotle's first law, right? His first law just said that every object wants to continue in the state that it's in. So basically, continue in the state of rest or in the state of motion in a straight line at a constant speed. Okay, unless it's compelled to change by the state of forces exerted on it. Okay, so basically we also called this. Basically, this is also called the law of inertia. Things move according to their own inertia. Okay, and they want to basically the objects want to keep doing what they're already doing. Okay, some examples of these are like a hockey puck on ice. Okay, a rolling ball, a satellite in space, coffee in a coffee cup. Okay, it just wants to keep doing what it's doing. Okay, and so inertia really depends on mass. Okay, and so basically the greater the mass that an object has, the greater inertia that it has. Okay, so generally we're going to be measuring these in terms of kilograms. So basically when we start to look at it, which has more mass, a kilogram of lead or a kilogram of feathers? Mass and volume. So volume is how much space something takes, okay, or how much space something occupies, where mass is the amount of space, the amount of stuff that's in an object. Okay, so how do we experience inertia? Right, inertia is a resistance to shaking. So like if you went out on a boat, on like a little rowboat, right, and you're walking into the boat, you're gonna be swinging that boat back and forth. Compared to if you step onto a yacht, right, you can walk all over the place. You can go and stand right on the edge, and it's not going to do anything. Okay, so which makes it easier, right? So which is easier to shake, a pin or a person? Okay, and think why that might be so. Okay, so why is it hard to stop a heavy boat? Right? Why can't you just stop it in place? Okay, so mass versus weight. Mass is the intrinsic property that an object has. Weight measures the amount of gravitational force on that object, okay, due to the planet or large body in which you're next to. Okay, so weight depends on the location of the object. Okay, so here's the first question, right? How does mass of a rock compare when compared to the Earth as when it's on the moon? Okay, how does the mass change? Question 2, how about the weight? What's it gonna change, right? Is it going to be heavier on the Earth or heavier on the moon? Okay, so kind of a review, mass and weight, right? So what is mass? Okay, so basically the quantity of matter that's something that it goes into. Okay, so what is weight? Okay, the answer, force due to gravity. Okay, so weight of 1 kilogram. Okay, so going to give you guys kind of an idea how much a kilogram is. Okay, so generally when we're using weight, okay, 1 kilogram weighs exactly 9.8 newtons. Okay, which is about 2 pounds. Right, so compare the weight of 1 kilogram of nails to 1 kilogram of styrofoam. Which one's going to be heavier? Okay, the answer, they're the same. Okay, they're both 1 kilogram. Okay, so some weight examples. What does a 70 kilogram person weigh? Think back to our previous question. Okay, if 1 kilogram weighed 9.8 newtons, how much would 70 kilograms weigh? Okay, so the answer, so weight, which is basically mass, times gravity. Okay, so 70 kilograms times 9.8 newtons is going to be 676 newtons. Okay, so when an object weighs 9,800 newtons on Earth, what is its mass? Okay, look back at this previous question. Okay, so the weight, okay, it's 9,800, so you divide it by 9.8, that's going to give you 1,000 kilograms. Okay, so let's go ahead and do a little bit of a quiz. Right? Imagine a place in the cosmos far from all gravitational and frictional influences. Suppose an astronaut in space throws a rock. Right? What is the rock going to do? Is the rock going to gradually stop? Continue in the same direction at a constant speed? Okay, so 2. A 2 kilogram object is moving horizontally with a speed of 4 meters per second. How much net force is required to keep the object moving with the same speed and in the same direction?